Man, it is now like clear that a lot of engineering students don't understand what parallel and series connection is. Meanwhile, it is one of the most important aspects in engineering that are applied in all aspects of engineering. But don't worry, today I'm going to explain it to the very basics using practical. Now, before we start, let me quickly show you something. Now you see, there is a difference between knowing how it was done and understanding how it is done. Now, when you know how it was done, it means that you are only going to use the exact same material to duplicate the exact same thing. But when you understand how it is done, it means every material you find around you is the material for the work. For example, if you say you understand, but yet you can't explain the function of this using this, then you never understood it. If you understand something, then you must be able to explain it using almost everything around you. So I've asked a lot of students this question, a lot of engineering students this question: what is the difference between series and parallel connection? And a lot of them were giving me answers like parallel connection is when you connect the positive to positive and negative to negative. Series connection is when you connect negative to positive and negative to positive. Now, if it's all about connecting positive to positive and negative to negative, what about component like an inductor? Can you still explain it using that? What about components like non-polarized capacitors like mica, film capacitor? What about components like transistors? Let's even bring it to real life things. Can you still explain that same thing using real life events? No, then you never understood it. Okay, guys, so when we talk about parallel connection, it's when two things, A and B, when two things, A and B, has a direct contact to another thing, which is C. So when two things have a direct contact to a third thing, C, it means these two things are in parallel. But when we talk about series connection now, series connection is when two things A and B, two things A and B have a contact to a third thing C through each other. This is series connection and this is parallel connection. So B cannot access C except it passes through A, and A cannot access C except it passes through B. So either way, the current still flow across each other, not directly from C to A or C to B. So this is series connection and this is parallel connection. Now, components can also be connected in parallel to each other or in parallel to another component. And they can also be connected in series to each other and in series to another component. I'm going to use battery for an example. For a battery, if we say they are connected in parallel, that's for component connected in parallel to each other. For battery, if we say these two batteries are connected in parallel, it means that the positive of one battery will be connected to the positive of another battery, and the negative of one battery will be connected to the negative of another battery. This is when these batteries are set to be connected in parallel. So if I'm to put a load on these two batteries, let's use the load as the third thing C. So this is battery A and battery B. The load becomes C. Now, if I'm to connect a load to these two systems, let's use a light bulb as a load. So if I'm to connect a load to these two systems, if you look at it in parallel connection, you see that the two batteries both have direct link to the load. So if this battery is being removed, if battery A is being removed, battery B will still be running the load. And if battery B is being removed, battery A will still be running the load. That is what it means for batteries to be connected in parallel. Now, let's say if these batteries are connected in series. So this is battery A and this is battery A and battery B. So if you look at this very well, let's say we are using these two batteries to run a load, which is a light bulb. You will see that each batteries have contacts to the load through each other. So if I should remove battery B, the load will stop running because the power at which battery A is transferring to the load is passing through battery B. So if I should remove battery A, battery B will stop supplying the load. That is how series connection works. So what happens to the voltage and current of the battery when connected in series and in parallel? When you connect batteries in series, the voltage of the battery will increase. So let's say battery A is 5 volts and battery B is 5 volts. The total voltage should be equal to 10 volt. Meanwhile, the current will be the same. So let's say battery A is 1 amp and battery B is 1 amp. So the total current will be equal to 2 amp. Sorry, the total current will still be 1 amp. Sorry, it will still be equal to 1 amp. That's when you connect batteries in series. The voltage will increase and the current will remain the same. But if you connect them in parallel, let's say they are connected in parallel, what will happen is that the voltage V of the battery will remain 5 volts. Meanwhile, the currents will increase, will be equal to 2 amp. This is what happens when batteries are connected in parallel. The voltage remains the same and the current increases. So guys, these are 100 ohms resistors. So we are going to be using it to see the effect of parallel and series connection of resistors. This is a current meter, volt and current meter. Right here will give us a display of how much current is drawn by the combinational resistors. So let's begin. This is our power source, positive and negative. So what I'm going to do first, I'm going to use the first resistor, load it across the power source. This is in parallel to the power source. So one terminal is connected to the positive and the other terminal is connected to the negative. Now, if you look at the current meter, it's reading 0.17 amp. That's the current reading. Now, what happens if I parallel another resistor to it? Now, understand that parallel and series connection, when paralleling, the two components have direct communication with the source. So these two resistors has a direct contact to the power source. Now that the two resistors are in parallel, if you look at it, the current is now reading 0.22 amp. So now what happens when you connect a resistor in parallel? Resistors are measured in ohms. They are measured in ohms, and the purpose of resistors are they opposes the amount of electrons flowing through a circuit. So what happens is that when you connect resistors in parallel, the resistance of those resistors will reduce. If you connect them in parallel, their resistance will reduce. Therefore, more current will flow through both resistors to the outputs. So Here we have 100 ohms and another 100 ohms. Because they are being connected in parallel, the current flowing through them will divide their resistance by 2. So we'll now have 100 ohms divided by 2, which will now have 50 ohms resistor. So the total combination or combinational resistor will now be 50 ohms. Therefore, more current will flow through the resistor. That's what happens. So what happens when you connect resistors in series? Remember, I said in series, one component have a contact to the source through the second component or through each other. So in this case, we now have the negative and positive terminal connected across both ends of the resistor. And if you look at the current reading, you see that the current reading is equal to as if as though we were connecting the one resistor across positive and negative. So we're now having 0.15 amp of current. Now, why is it so? Why is the current not doubling? Because we are still using two resistors. What happens is that when you connect two resistors in series, their resistance add up. So instead of their resistance decreasing like in parallel, it will increase. So we now have 100 ohms plus 100 ohms, which will now give us 200 ohms. Using Ohm's law, if we do the normal current calculation, which is V over R, you will now see that the amount of current will be 0.15 amp flowing through them. So that is how parallel and series connection operate using resistors. And the next component will be inductors. Inductors are said to behave like capacitors, and sometimes they can be used as a resistor. Before I continue, let us look at what an inductor looks like. Now, this is an example of an inductor. It's simply winding a wire into a coily shape. When once you wind any conductor, any insulated conductor into a coily shape like this, that becomes an inductor. And what happens when inductors are connected in series and in parallel? I'm going to use the symbol to explain. Now, an inductor stores electrical charges in form of electromagnetic flux. That's how they store electrical charges around them in form of electromagnetic flux. So, inductors can be used for several things like boosting voltage and current, and also you can use it as a resistor and also for wireless technology. Now, what happens when you connect an inductor in parallel? Due to the characteristics of an inductor that it stores electrical charges, it's simple. One inductor can store a certain amount of electrical charges, but when you connect them in parallel, they can store double or two times the power of what one inductor can store. This is a parallel connection of an inductor. And then what happens when you connect them in series? So when you connect an inductor in series, first the resistance of that inductor will increase because the number of turns is now higher than what it was before. In parallel, the number of turns will remain the same, but and the resistance will remain the same. But in series, the number of turns will increase and the resistance will increase. What happens to the output power? The output power will also increase in terms of the volts will increase, and the current on the other side will remain the same. The voltage will increase and the current on the other side will remain the same. Meanwhile, when connecting in parallel, the current will increase and the voltage on the other side will remain the same. That is how inductor behave when connecting them in series and in parallel. So just like a transformer, if you want more voltage, you need more turns. And if you want more current, it's either the cross-sectional area of the inductor must be larger or you can wind them in parallel. That is how it works.